Hi everyone. Hi Rachel. Now we are going to start from 5 chapter 7 quantum physics. Short notes and exercise. Okay, this quantum physics actually got a few subtopic lah. But I find out that the subtopic is number one, what is the quantum theory of light, which is recorded as black body spectrum. And under black body spectrum, we got E equals to HF and many things. Okay, I I don't focus this part, because this part so far less question in trial. I'll directly focus on photoelectric effect. So come to the Einstein study lah. So direct lah. Okay, yeah, a bit related but not too much. I'll focus on this formula first. Okay, then the application is about solar cell and light detector, door, and image sensor. I don't know, so never mind. Okay, we focus on photoelectric effect today. Okay, so this is the summarize lah. So we start now. This one I won't touch much. All right, so now, first of all, we need to know what is quantum physics. So this is also from your textbook. So physics is classified as two parts or two generation. Number one is the old one, but of course we don't say old, we say classical. Then the new one we call quantum. What's their difference? But anyway, if anything not so sure, you can type your question or directly on your mind. I wonder where are you get the bowhead? Is it in the Zoom? Okay, it's okay. Now, okay, so actually got a lot of scientists and physicists involved. But we only focus on eight. So the history you all memorize a bit. So far, I only see objective ask the question. Okay, classical theory is, of course, our Isaac Newton. He studied a lot. So we learn what? We learn Newton's first law, second law, third law of motion. We learn Newton's universal law of gravitation. Yeah, he really can say he's the fathers of physics. Okay, then quantum physics. What's the difference between the classic physics? Quantum physics is talking about the one more. Classical theory, we can say this is macro physics. And quantum physics, we call it as microphysics. Macro is like something you can observe by your naked eyes. For example, force. Force moves something. For example, you can see the sun, you can see the earth moving. Okay, all of this macro physics. Okay, then quantum physics I would like to say it's all most I would say it's focusing more on light lah. More on light. Okay, yeah. Our then so first of all, England no Ebola. Okay. And then second is this is the rumors that say Newton is hit by Apple computer. No, hit by Apple. Actually, is Newton think this for a long time already. And at that time, the Apple just fall beside him. Then he get the idea of universal law of gravity. Okay, that's that's another topic lah. So about light. Okay, light. Let's see what is their discovery or assumption about light from classical theory. Okay, so first of all, Isaac Newton in 17th century, he said the particles, he said the light can be a particles. The light is like particles. But the problem is, after about 100 years, come to Thomas Young. Thomas Young, he did the very famous and important experiment, okay, which we learn in Form 4, Chapter 5, Young double slit experiment applied to. Okay, Young double slit experiment talking about, okay, thanks to this video kind of.
Best protection from ultra-long UVA, powered by Nexeril 400.
Use code SYOK10 and get 10 ringgit off your favorites.
In this video, we will understand Young's double slit experiment.
The experiment is a remarkable one that reveals the wave nature of light.
A Young double slit means when he opened two slits and let the light pass through. So we will see.
Thomas Young performed this experiment in 1801, and it served as the first evidence for wave theory.
We will see. Last year we do this for water wave only. So we will see interference pattern, which is one crest, one trough, one crest, one trough. Okay. So what he proved? He said that no, light is wave. Newton say light is a particles means like molecule or atom light. But Thomas Young proved that light is a wave. Okay, then come to John Dalton. At the same time, John Dalton made the Dalton atomic model, which you all learn in chemistry. He said the particles, the small at that time the smallest particle is atom. And then inside got proton, electron, neutron. Inside got proton and just atom. He say atom is the smallest particles because at that time like that no machine. So must be the first person discover the first knowledge. Then come to J.J. Thomson. See, also around 50 to 100 years. A.J. Thomson say what? Oh, atom is not the smallest particle, still got electron. Okay, so yeah, chemistry and physics sometimes related lah. Okay, now classical physics almost ends here. Then comes to yeah, even though they say Newton said light is particles, or Thomas Young said light is wave, also cannot solve the problem. Solve about some problem. What's the problem? About this. We thought, yeah, Form 4 we learned light is like a continuous spectrum. But they find out, eh, sometimes the spectrum come up from the metal is a line. So they use all of the classical theory and all of the physics formula, also cannot solve the problem. Some more, they use more classical formula to calculate about light spectrum. The results is really very far away lah. So they can't explain the light spectrum problem. Then now comes to around 1900. Yeah, really around here. So actually quantum physics just around 100 over years. But classical physics already a few hundred years lah, the study. So now actually no one can say they really understand quantum theory. It's still a very, very new field in physics lah. Okay, but if you want to study this, you need to know a lot of skill in maths lah. Okay, so Max Planck. Yeah. So Max Planck, Planck. 华语叫普朗克 Max Planck. Max Planck, he also studied this and he come out a new idea called quantum. Quantum means he said light is a discrete energy. Light can be, of course, the light come from sun, can be a continuous energy. You can see, not the continuous. But he said light also can be a discrete energy. Discrete here means individually. You all learn in chemistry, right? Not stick together, right? Individual, discrete. So they come out the words quantum. So actually, what is a quantum? So this is explained more further by Albert Einstein. Yeah, they are good friends at that time. Okay, so Albert Einstein say the discrete Albert Einstein said that he complete the idea of quantum. He said quantum energy as a photon. Sorry, this one I type one words. I missed one alphabet. Photon, not photo. Photon. Photon energy. Albert Einstein said photon energy. Please correct here. Photon energy. So later I create a quick quiz. Got this question. So those who cannot answer this means they didn't watch video. Okay, photon energy is directly proportional to the light frequency. So you might ask, by to photon energy. Okay, photon energy, you can remember it as an energy packet. Photon energy is energy packet. Nah, this one, this light spectrum is a photon energy packet. And from here, yes, we need to recall what? We need to recall the rainbow color. Right? So for Chinese, normally we study in primary school already lah. 红橙黄绿蓝靛紫. Okay. Okay. If you haven't yet memorized yet, please remember this. Roy Gibbons. It's a must. Red, orange, yellow, green, blue, indigo, violet. So I remember Roy going to give birth. Okay. Roy give birth. Roy give birth. Okay, then why we need to remember this? Because red got the longest wavelength lambda, but it has the shortest frequency. Violet has the shortest lambda, but it has longest frequency. So, photon, Einstein said photon is energy. Photon actually means light energy. Light energy. The photon energy, actually can just say photon already. We know it's light energy. But I would like to remind you photon is energy, so I'll always say photon energy. That was very new to you, right? But to photon, I would say it's photon energy. It's directly proportional to light frequency. So means since purple has the highest frequency, means not purple, sorry, violet. Violet will have the greatest photon energy for visible light . So as we know, in front of the spectrum still got what? Still got RM, IVU. Radio wave, microwave, infrared, this is V means visible light, X gamma. U means ultraviolet. Ultra means more than violet. Infra means less than red. Infrared. Okay, so ultraviolet will have the frequency more than the visible light. And of course, we cannot see ultraviolet. Okay, so now comes to the Niels Bohr. Niels Bohr, he observed that they almost live in the same generation. He said light spectrum form when electron transit among shell. This one. So we know Bohr's model, he said it got electron. So when electron get energy, it may jump to the higher level. The electron may jump. Okay, so when it jumps, it will release some spectrum, some light, some color, some light lah. Okay, so and actually not only one electron will jump on one time. Maybe got a few electron jump on the same time. So can you see? Got a few color of light lah. So that's why when they jump, when they move, when electron, we don't say electron move lah. We say electron transit among the shell. Shell means you all learn chemistry lah, huh? So they will release out a few color. That's it. This is called line spectrum. This color form because when electron jump from shell to shell. Don't say jump. We say transit. Electron transit among shell will give out a line spectrum. Okay, and then what is the advantage of this when we see line spectrum? So when we find out one material, for example, meteoroid. The rock that from meteor dropped to the earth called meteoroid. 陨石. Okay, for example, if you got one meteoroid 陨石. Meteorite. Yeah, it's from 2 chapter 11. Yeah, it's meteoroid. When it's dropping on the earth, it's called meteor. And when it drop on the earth, we call it as meteorite. Already on earth. Okay, so normally when it drops to our earth, if we want to test the meteorite, we can use this line spectrum. We can shine the light on the meteorite and we observe the line spectrum it gives out. So every material got fixed line spectrum. For example, if inside got iron, the line spectrum like type A. If inside got titanium, it's type B. So from there we can see inside the meteorite got how many material. Okay, then maybe it will bring some material that never see on Earth. Then we discover new material. So your periodic table got one more material. Your periodic table. Some material is found on meteorite lah. But Form 5 we didn't learn that. Form 5 we just learned a very common one. Yeah. Why do some color have two lines? It's their pattern. I'm not too sure how the line is formed. I just know the line is formed. Yeah, so and of course the line also always got the fixed length. And by the way, this is in nanometer. Do not worry. Form 5 won't ask you to memorize the spectrum pattern. Do not worry. Just tell you this is line spectrum. When electron transit, they will form line spectrum. Just need to remember it. And apa itu nano? This prefix nano means 1 times 10 powers of. Okay, for example, this one is in around 500. So 500 nanometer means 500 times 10 powers of what meter? Must change. Must be alert. Nano. Change. Change to the prefix standard form. Please press your calculator and tell me. You press 1 nano. You press on your computer or on your calculator. 1 nano. Press 1 nano. Anyone? No one can find? Okay, there are two ways. One is you directly press 500 nano. One is you press 1 nano. Ayo. Oh, prefix. Ayo. How are you going to hide? Yeah, this is the prefix. Yes, yeah, correct. Nano is times 10 powers of negative 9. Yeah, press your calculator. How? Ask your friend or go Google search. I taught many times already. This one. Option 3, nano number 3. Okay, then some of you might say, oh, this is supposedly negative 9. Some of you, when you press, you will get 5 times 10 powers of negative 7. Correct? This is translation of nano. Then this is the standard formula. Okay, 500 times 10 powers of negative 9. Or you directly press 500 nano, your calculator will directly convert for you. Okay, and the old type one is nano. It's shift 3. Shift 3. You must have yourself. Okay, so be careful. This chapter got a lot of line color. Color got wavelength in nanometer. Okay, line last. So Neil Bohr said line spectrum form. Form means produce when electron transits among shells. Shells. Transit. Then finally, come to Louis de Broglie. He's a French. If I'm not mistaken, his name is Louis de Broglie. Of course, if it pronounced in Bahasa is Louis de Broglie. No. Actually, it's de Broglie. Okay, he comes to the wave particles duality theory. Apa itu? Means light could be wave and could be particles. Apa itu? Form 4 we learn light is wave. But Newton said light is particles. Finally proved by Louis de Broglie. Light is a wave and also a particles. What? Yeah, okay, yeah. Okay, then comes to this is this one you all didn't exam, not exam. Then comes to a person. His name is this scientist not in textbook, no need remember, but I feel quite funny. Okay, because it's about cat. Yay. Yeah, so quantum mechanics. No. Actually, in quantum physics, uh, got many experiments related to cat. So first is the Schrodinger's cat. Uh, it is him, Schrodinger cat. He's a German. Schrodinger's cat. You might find out, why the front so familiar? Because there is an electric brain called Schneider. 对对对，薛定谔的猫。Okay, it's both different and indifferent at the same time. Okay, what this is just a thinking experiment. No cat is harmed in the experiment and not exist in your exam. Just a fun fact lah. Okay, so Schrodinger say, what is the wave particles duality? Okay, he said, oh, in the box, inside the box, is a closed box. It's a closed box. Inside a closed box. Okay, there's a cat. Okay, then this cat, inside here got a radiation that will activate, trigger an experiment. A switch lah. So when the radiation randomly, we don't know, randomly triggered the switch, it will hit the poisonous things and makes the cat die. So before we open the box, the cat could be alive and could be die. So before we observe it, it could have two conditions. So we say it's a duality inside. Then when can we know when is wave, when is particles? Or we say when the cat alive, when the cat die. It's because it's only you can detect when you open the box. Oh, alive. Oh no, die. By the way, this is a thinking experiment. No cat was killed in this experiment. Okay. So, how do you know the light is wave or particles? If you measure it by using Young's double slit, it's a wave. Then if you measure it by using, I forgot what experiment name already. If you want to measure the light as a particle, then it is particles. So yes, the light got wave particle duality. That's the fun fact. No, it's the history of classical theory and quantum theory. So the Schrodinger cat, do not worry, won't exist. Just a fun fact. Okay, now what you need to do. Number one, Isaac Newton said the light is a particle nature of light. Thomas Young proved. He used double slit experiment to prove light is a wave. John Dalton, he made the atomic model, and J.J. Thomson said inside the atom got electrons. Okay. Normally they don't ask. They don't ask. So what you need to memorize is you memorize the quantum history. So 1900, Max Planck, Max Planck, this what is it? He invented he discovered He discovered the phenomenon and he named it as quantum. Quantum means energy is discrete, so discrete energy. Quantum is discrete energy. Max Planck. Then come to Albert Einstein. He invented a name called photon. Photon is energy, and photon is directly proportional to the light frequency. Comes to Niels Bohr. Okay, Niels Bohr say light spectrum, light spectrum form when electron transits among shells. Then finally come to Louis de Broglie. He said light got duality, which is can be wave, can be particles. Okay, then here's got another some small fun fact lah. Albert Einstein said the God never throw dice means mana boleh wave and particles duality. Physics is a certainty, cannot be a probability. At that time they quarrel lah, not quarrel lah. Can say quarrel lah. They quarrel about it lah. Blaise de Broglie said, yeah, the light got wave particles duality, but cannot show. It's not a certainty, but probability. Then Einstein asked, how sure you are? What's the certainty? So that's why we got the phrase, God never threw dice. You all go search. By the way, that one not important. For you, very important is Max Planck, quantum is discrete energy. Albert Einstein said photon energy is directly proportional to the light frequency. Niels Bohr say electron transit among shell that will produce light spectrum. Louis de Broglie say light has wave particles duality. Okay, 1 minute, I'll call your name for quiz. Two. Dun, da, da. I follow sequence. Jia En, Max Planck say what? Mimi is staring at you. Quantum, yes. Light comes to the Einstein. Einstein say what? Light, dun, 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 like Aaron and Aaron, Aaron and Aaron. Okay, sleeping. Right, Kevin. Let me check Kevin. Oh, Kevin. Oh, Aaron. Yeah, okay. Photons. Kevin. Kevin. Max Planck say what? Don't look at your paper. Max Planck say what? Recall now. Don't. Yeah, I say quantum is individual energy. But individual is the explanation. Right? You all should memorize quantum is a discrete energy. Yeah, discrete is strange, very like strange to you, but you need to follow. You need to follow the words. Cannot use synonym to replace it. Not individual energy. Quantum is discrete energy. Okay, everyone, be careful. Quantum is discrete energy. So that's why when I mark paper, many people like forgot the new words lah. So use synonym. Cannot. I know news boss say what? Right? Let me ask a few person. News boss say what? Ashfani, Jian Wei, Jun Lam, and Jen Sang. Ashfani, Jian Wei, Jun Lam, and Jen Sang. Ashfani, Jian Wei, Jun Lam, and Jen Sang. Fast. Just give me key. What's the key? Yeah, electron transit and will form lines. Sorry, 3 more%. Jen Sang. Yes. Emits photon curve. No. Must follow back. Must follow back. Yeah. Something like emits photon, but no. Must follow back the textbook. Yes, Junlam, yes, very good. Yes. Light spectrum form when electrons transit among shells. Yeah, I agree with you lah. Some like some like you change sentence or what seems can. But I would like to say lah, knowledge got no absolutely right or wrong, but exam got. So because exam we must have the exact question, exact answer, which we can refer. You will find out why IGCSE can use this word, but SPM cannot. Exam lah. So every exam got their centralized textbook, so we must follow textbook lah. You don't Google especially the definition. If you Google sure wrong, must follow textbook. If I replace among to the other, okay. Like among to the other can, but the key, if you replace like discrete energy, you say individual energy wrong lah. Okay, must follow which exam, follow which textbook. So let's say next you are going to take A-level exam. Please follow your A-level textbook, the definition, all right? So last, the bright wave particles duality. Okay, so now comes to the what is energy packet. So now the light spectrum is like this. So this energy packet is light spectrum. Then the continuous matrix is called continuous spectrum. Okay, light. So light comes to this. Quantum energy is discrete energy packet. Now, this is quantum energy. It's discrete energy packet and not continuous. According to Max Planck, second page here, and Albert Einstein, they are good friends. Okay. Okay, so light energy exists in the form of energy packet known as photon. Photon, okay? So the photon energy is directly proportional to the frequency. So we got this formula. E is directly proportional to F. Then, since we learned from 5 chapter 1 maths, we know that if we want to change a directly proportional into an equal sign, we must get a constant. So this is Planck constant, yes. Yes, Planck, he find out no matter what color of energy, the proportion always is this. And you will, let's say you forgot. I always forgot. You can find it out in your formula last under quantum number 11. So Planck constant. So it seems like the pi lah. Circumference of a circle is directly proportional to its diameter. So we say circumference is equals to pi d. So the relationship, the proportion is always the pi lah. So C over D is pi. Okay, so this one the same thing lah. E over F. E is equals to HF, so E over F equals to H constant. So no matter what color light, the energy divided by the frequency always get the same constant. Okay, then next, light energy, E is transmitted in energy packet known as photon. So E equals to HF. So photon is light energy lah. So for electromagnetic wave, the relationship between the wave and speed is actually this is come from your Form 4 chapter 5. E equals to F lambda. Also you can see here so V equals to F lambda, quantum physics. So what is C? C actually is speed of light, which is 3 times 10 powers of 8 equals to F lambda. So then what can we say? We say F equals to C over lambda lah. C already fixed. It's light. So got light speed lah. So we also can substitute F as C over lambda. Yes, then we create a new formula called E equals to HC over lambda. Then you might ask what's the difference? Very easy. When the equation give F frequency, I use this formula. When the question give lambda, I use this formula. And we already know just now lah. The wavelength of light always like 500 nanometer, around that or 700 nanometer. So means it is 500 times 10 powers of negative 9 meter, or we say standard form 5 times 10 powers of negative 7 meter. Depends on how you press your calculator. Old style one, I will always like to change nano to 10 powers of negative 9. or you just directly press 500 nano, correct? Now, so Louis de Broglie also say it's a wave, but also it is an particles. It is a particles. So yes, it got momentum and wavelength. Then I'll skip this first. This one really, I don't see much in Excel trial yet. I leave this first. I'll directly start the photoelectric effect. Then page 3. Yeah, because of this, then we have solar cell, right? Like, see, so what is photoelectric effect? Like, photo actually means light. Electric actually means electron. Electron is emitted out. Electric means the electron moving out. So we say it's emitted out. Effect means when got light, got current flows. So apa ini? So we read the questions, main sentence first. When a metal surface is illuminated, means shone, is shone. Means is shine lah. Means shine lah. You shine a light on metal surface by a beam of light, or you don't want to say a beam by light lah. At certain frequency. I must mention frequency. Electrons can be emitted out from the metal. Basically means if you got one light shine on a metal surface, electron will be moved out. But don't use the common word. Please use the proper name, proper words in the sentence. Okay, this one, if every word's the same lah. If you want to say electron emit out first, then you say shine by a certain frequency also can. Don't you feel this is familiar? It's almost the same as thermionic emission. Thermionic is we heat up the metal surface, then got electron emit out. Yeah, so not only heat, light also it will emit out. Okay, if you cannot remember illuminated, you remember shone. Means you shine a light on metal surface, it will release out the electron. Okay, so this is thanks to this professor.
One of the big ideas in physics is that light can behave as waves on a zinc plate. And if you want the demonstration...
And this is a zinc plate. So he makes the electroscope open, means here got charge. So what happened if he...
Now let me show you that again. I've got a perspex rod here.
You don't care this. They care what? They care, look at the light. Here got, this is normal light, this is UV light. See what happened?
Watch what happens when
this is normal light. I think orange or orange. It shines on it. Anything change the electroscope?
Absolutely nothing.
Absolutely nothing.
That's actually a really important part of the demonstration, just that what happens when I shine.
Yeah, you can't see anything, right? It's UV. If you can see, you are Superman. Okay, UV shine on it, electron release down, then neutralize the electroscope.
You can see that the gold leaf immediately starts to fall.
Okay, why? Because electron release out downward. UV. So most of the time we use UV when a beam of light with certain frequency shines on a metal surface, electron is emitted out. Just now it's positive lah. So emitted out means it will neutralize it, so it closer. Of course, we cannot see UV, we cannot see electron, so we use this to show electron is emitted out. Okay, memorize already? Give you 1 minute fast. It's a must, huh? It's a must. Normally A will ask this. What is photoelectric effect? Or what is threshold frequency? 1 minute, huh? Illuminated 华语就叫照当那个光有某个频率的光照在金属上，电子就可以被 emitted out. Okay, done. 来，噔噔噔。So as long as you have key, the sequence you not follow doesn't matter. Dun, dun, dun. 来 tell me from the rest also you can try to test yourself. I want Tiffany, 魏忠, 郑亮, 郑浩. Right, Tiffany, 魏忠, 郑亮, 郑浩, and Kaisi. Tiffany, 魏忠, 郑亮, 郑浩, Kaisi. The rest you also can type to test yourself. What is photoelectric effect? Oh, you forgot frequency. I Zheng Hao had frequency. Yes, Michelle. Tiffany. Yay, good. Starvish. Yay, good. Zheng Liang. Yay, good. Kai Xin. Yes, good. Wei Zhong. Yes, good. Okay, Zheng Hao, but I prefer you say when light at certain frequency is shone on a metal surface. Okay, good. Now let's continue. Okay, then actually how it works. So now look at this diagram lah. So this is inside the metal. Got free electron. Of course, got proton, neutron, but we just draw the electron here lah. Okay, then let's say the yellow light got 10 joules of light energy, which is photon, and we call it as photon energy. It's actually photon already energy, so photon already is energy. 10 joules when it shines on the metal surface. You remember, I believe you all remember the electron got attraction force. So if you want to break bone inside, it needs to absorb 4 joules of energy. Then only it can emit it out. So 10 joules minus 4 joules, yes. We left 6 joules to move it out. Okay. So this is the idea. 10 joules shines, 4 joules absorbed break bond, and 6, so left 6 joules move out. Then next, what should you do? You need to remember the name of each energy here. Okay, so 10 joules of light ray, we call it as photon. Can the name must remember photon is energy. Like second, absorb 4 joules of energy to break bond. This absorb to break the energy used to break bond, we call it as work function. Comma W naught. Photon, by the way, is the symbol is E. Then come to the last. Hey, what is the name of energy that move object? Which you can find in your formula list. Thank you, honey. Thank you, Sabish. Yes, it's kinetic energy. Thank you, Tiffany. Yeah, formula is here. Name is here. Yeah, it also makes kinetic energy. Because normally we carry this out in vacuum. So yeah, this is kinetic energy. Normally what we write EK max. Okay, so we can get the idea. Photon maximum absorb 4, get out 6. So yeah, we can say photon energy equals to work function plus KE max, which is totally 10 joules absorbed by 4 joules, go out with 6 joules. This is a rough idea, of course, not 10 for 6, but I feel a rough idea here helps you out. Then I come back to the textbook. Textbook say what? Textbook say photon energy is the light energy equals to work function actually means minimum energy required to release a photoelectron. Or you don't want to say photon, you might have to release electron. Okay, then Ke max is maximum kinetic energy of a photoelectron. I think the electron that come out because they absorb photo. Photo means light energy. Yeah, photoelectron. So the electron emitted out called photoelectron. Then, so if you know the relationship already, then it's the time we can substitute in the formula. So photon energy is HF, which we learned just now. E equals to HF. And work function, you can see I make a note here, but the textbook doesn't put a note. Work function, I would say it is HF, but this F depends on the material itself. Every material got its fixed work function. So it got its fixed frequency. By the way, this F node got a name later. Okay, so later. So F means the F for light energy. This is the material frequency. And Ke max half mv square maximum. Okay, now come back to F naught. What is the name of F naught? F naught, we call it as threshold frequency. This chapter, many new words to you. Threshold frequency. Again, this energy, photon, absorb, work function, go out, kinetic energy. Formula for photon energy, HF, F of light. So red light got one frequency, yellow light got another, blah, blah, blah. Work function, the F node depends on the material. Plus half mv square, okay? Seems like you understand. Okay, so now comes to a problem. The light with certain frequency only can release. Means the light must have the energy more than 4 joules. Let's say, I fix it, work function 4 joules. Hi, Michelle, threshold frequency isn't the same as frequency of light. Yeah, no. It's the frequency of material. The F without O is the frequency of the light. F note, I would say O is a note, note. Anti-nodal line, nodal line, note. Note means original or nothing. The threshold frequency is the material itself. Some material maybe absorb 4 joules, already can break bond, then electron go up. Some maybe need 9 joules. Some material depends. Sorry, they will give. They don't give also, you can find. Where do I get the F note? They will give in question. They will give. Okay, like now comes to a question, which is the photon energy. Light energy in the packet increases. Kinetic energy of photoelectron also increases up by 2. Now, for example, green light is 10 joules, absorb 4 joules of work function, go out with 6 joules. Then violet, just now we say violet, it has the highest frequency. So the photon is the highest too among the visible light. Then, so let's say 15 minus 4, you will get 11. This is the metal. And I believe you all see this already. Dun, dun, dun. So the red photon frequency is too small, not enough, only 3 joules. So how much you need to emit out electron? Let's say 4 joule. Sorry negative. So no electron, no kinetic energy. Like, let's see. Lonnie. Yeah. Thanks to Lonnie. Lonnie showed us the experiment.
We're in the demo lab with Lonnie, where he set up a photoelectric effect experiment. He has white light impingent on a metal.
Okay, white light means we got 7 color. So maximum got UV. So you can see this is the milliammeter. By the way, this is called a photocell. Photocell, which you can see around here. Photocell. It's a circuit lah. It's a circuit. Dun, 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 dun. Then you might, oh my God, graph. I tell you, this graph very easy to answer. This one. So this is cathode, this is anode, same as the cathode ray. But this time we don't heat up. We give ray, we give light E equals to HF. Then it will have photoelectron emitted. So when photoelectron emitted, it will go straight to the anode and flows across the circuit. So you will see galvanometer deflect lah. Then be careful, Be careful about what? Be careful about this is galvanometer 0 later. Okay, so now if got photoelectron, then the galvanometer or the emitter will deflect. And as I told you, electron go from same thing. Okay, so now next. See, thanks to Lonnie, he demonstrate this one. Inside here got the metal, so the light shines on it. It will have electron that flows. I don't know where is this. Where is the wire? Where is the wire? I think like this, but the electron release and goes through the circuit. Okay, so
And the energy of the photoelectron
now this is the projection of the emitter, mini emitter.
electrons emitted
So you can see now, white light got 7 color of light, so 7 frequency also got. So you can see maximum current.
are shown on the meter at right. If he puts a red
Now here you can see here. Red light is a red photon.
filter in the path, now only red photons can strike the metal, and you can see they do not have sufficient energy to eject photoelectrons.
So remember, red light do not have enough energy to eject, to let the electron emit out.
If we go to higher energy photons, say go to yellow light, that's shorter wave.
So let's recall Roy Keeper. Must memorize. If you don't memorize, I cannot help you. The red cannot, but now it's yellow or orange, you see. So actually they are increasing the frequency.
Wavelength and higher energy photons, they may be able to eject photoelectrons.
Yeah, a bit.
And indeed, photoelectrons are emitted, but with a relatively small energy. If we go to higher still photon energy, green wavelengths, that's
Roy gave green at the center.
shorter wavelengths still, higher photon energies, we can see photoelectrons emitted at a higher energy. Now we can still go to higher energy photons. Blue photons, photons in the blue region, are the highest energy visible photons, and Lonnie has a blue filter that will pass only blue photons. Putting the blue filter in the path shows photoelectrons emitted at the highest energy. So here's an example of the photoelectric effect.
Thanks to Lonnie. Now get the idea. So get the idea. A red so why red photon no electron? So we can say that because the red photon means photon energy. That red photon is less than less than red photon energy lah. Is less than, what is W naught? Is less than, what is W naught just now? So we say photon is less than W naught. What's the full name of W naught? Anyone can help? Yay, thank you. Yeah, work function. Yeah, work function. Yeah. Okay. So if the photon more than work function, ta-da, got photoelectron. Okay, this one we see later. Now we directly look at question first. Like diagram 6.1 and 6.2 shows the effect of electron when red light and violet light are shone on the same metal surface. Same metal. What is meant by photoelectric effect? You can write now. Don't refer, you can write now. Everyone. Da. Okay, done. Now, based on 6.1 and 6.2, compare the wavelength of red light and violet light. They may say, teacher, I didn't memorize. Yeah, you are right. I also don't know actually. So who can help me compare? Who can tell me answer and tell me why you say so? I don't know the wavelength. How can I compare? Okay, yeah, 6.1 bigger than 6.2. Can I write this in exam? Yes, only for 5 and 6. Number 11, do not write this. Yeah, you're right. So we say the red wavelength is bigger than the violet wavelength. Yeah, actually, yes. This is what I asked you to memorize lah. Roy Gilbert. So red has longest wavelength but smallest frequency. Violet has shortest wavelength but greatest frequency. Then let's say, I didn't remember how. I didn't remember this. How anyone can tell. Okay lah. Actually, you can directly measure. Yes, please remember if you have no idea. I didn't study this chapter. It's okay. Number 5, number 6, you just use your ruler to measure. Wavelength actually is from crest to crest. Now, this is wavelength for red, and this is wavelength for violet. I can see already lah. Red wavelength of red light is greater than wavelength of violet light. Yes, you can measure. Really, you can use your ruler to measure. And then please remember, if you find out, the height like almost the same. Measure. Really, you measure. Measure with your ruler. Really, it helps. Yeah. All right, so now compare the electron effect for red light and violet light. Okay, I believe you all can compare. Can I say violet light has more electron effect than red light? Okay, I encourage you not to do that. Yeah, even though we always say more lah. But this one is obviously what? This one is obviously one have, another don't have. So I prefer you all write red light. That's right. Maybe you say violet light has electron effect. Actually, it's photoelectric, but sometimes they still say electron effect. Wow. Oh, but red light does not. Okay. Yeah, so actually compare got a few types. You can say number one, A more than B. Number two, we say A has, but B doesn't. Number three, we say A is X where B is Y. Like A is parallel circuit while B is series circuit. And also got number four, A same as B. Yeah, but very rare you will use 2 and 3 lah. Especially it's in very rare, but you can see this after chapter 3, the electric one. Okay, now compare the frequency of red light and violet. That's why you need to memorize this. So we say 6.1. Oh, yeah. Oh, I should say 6.1, 6.2. By the way, since they give red in 6.1, violet in 6.2, yeah, you can use red and violet too. But the frequency, of course, is 6.1 lesser than 6.2. So this one is we say 6.1 has, while 6.2 doesn't. Okay. So relate the electron effect to the frequency. Okay, if we can memorize the formula E equals to HF, so we say what? And also you remember the theory from Einstein. So E directly proportional to F. Okay, but I prefer you all use the hypothesis format. But of course, this one can use directly proportional, but I still encourage you all for safety still encourage you all say MV first then RV. So actually this is MV and this is RV. So we say frequency increases, electric effect increases too. When frequency, please start with when. Because paper 3, when you write hypothesis, please start with when. When F increases, electrical energy increases. Can I use arrow in exam? No. But of course, now we want fast, yes. Exam full sentence, yeah. All right, so now, given that the yellow light, lambda for yellow light 580 nanometer, so what you do, either 880 times 10 to the -9 meter or 5.8 times 10, 80 times 10 to the -7 meter, up to you lah. Directly change nano, calculate the frequency of the yellow light. So here got one hidden info lah. What is it? Hill's ruler. Yeah, correct. Thank you. Yes, yeah, we use this formula. F equals to C over lambda. Oh, actually, it's from your form 4 lah. P equals to F lambda. Light energy, C equals to F lambda. So for me lah, I like to use the form 4 form. Up to you. So for me, I like to do this, and F equals to C over lambda. 3 times 10 powers of 8 divided by 580 times 10 powers of 9. Answer. Remember, 3 to 4 decimal places. Then I will get 1 mark and what's wrong? Why I cannot get second mark, mark 1, mark 2. Yeah, thank you, Kaisi. Thank you, Savage. Thank you, thank you, Qing Qing. Thank you, Shen Qi. Come to the question. Hey, what's the unit for frequency? Um, 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 um. Yeah, hertz. So it's Hz. Yeah, I also saw quite okay, I got people forgot lah. So let's say if you forgot also doesn't matter. See, this is C is meter per second. Lambda actually is meter. So M and M cancel. You will get frequency equals to S. I mean, frequency is per second. Correct? Also, you can do this. I prefer you use hertz lah. But worst come to worst, you forgot. You can use per second. Because according to form 4, they don't have here. Actually, you got one formula called F equals to 1 over T, 1 over period. So actually frequency is how many vibration per second. Vibration, no unit, so we just write per second. But I prefer you all write hertz. Just give you an idea. Let's say in exam you forgot what's the unit. It's okay. You substitute back the unit, then you do indices. Also can get back the unit. Okay, so now threshold frequency for the metal is this. Predict the effect of electron when yellow light is shone on the metal. Explain your answer. Now see, threshold frequency for metal is this. So we say F naught is this. Then this is light energy. So you can see this is higher than this, right? So we can say, well, the electron, Will there got electric effect? Electron effect? Yes, there is. Electron. Why? Why you can use back this? You can use yellow photon is more than work function. Yellow photon is work function. Then you may ask, they say frequency or can, because they say E equals to work function plus K index. So actually what is E? E equals to HF equals to HF node plus K index. We don't care this because it doesn't, this, can I want to say, you want to change also can. Okay, so now we can say what? We can say F is bigger than F naught, no? So what is F? F is the frequency of yellow light is more than the threshold frequency. Get the idea? When they ask you to predict or they ask you to what happened, we can always recall out the formula. Any chapter also can. Frequency, see? How to get photon or work function times the Planck constant enough. So you can get the idea how to answer this. You either say photon energy is more than work function, or you say frequency of yellow light is more than threshold frequency. That's it. Okay, so if we understand this already, then we can, of course, we can do next. So this is an experiment used to demonstrate the photoelectric effect. So now the light shine on a metal surface. The light with certain frequency shine on metal surface. Electron is emitted out. Or you want to say photoelectron is emitted out also can. So I believe all of you can memorize photoelectric effect already lah. You write yourself, Right now, state one condition for electron to be emitted from the surface of matter. Okay, I want you the answer from anyone can tell. Why electron is emitted out? Thank you, Tin Heng. Yeah. Yes. Very good. Very good. Yeah. Very good. Yeah, Michelle. Yes. Yeah, Jun Lam. Thank you. Just now didn't see. Yes. Chen Sang. Very good. Okay, like everyone look at this. Look at this sentence. Is it okay? Yes or no? Very good. Yeah. Very good. You give very good. You give the example. Yes or no. Right, everyone? Yes or no, just Y and thank you, Hanun. Thank you, Kayan. Thank you, Jiawen. And I want to cry now. Uh, thank you, Michelle. Thank you, Tineng. Thank you, Shiqi. Thank you, Justin. Thank you, Shiqi. Thank you, Tiffany. Okay, majority say yes. A few say no. Answer is no. Oh, answer is no. Cannot accept. Why? Like, look at in front. In front is energy. Look at behind. Behind is frequency. Cannot compare energy with frequency. Like, please compare. Photon is energy. Photon energy is more than work function is energy. Frequency, compare frequency with frequency. Frequency of yellow light is more than threshold frequency. Get the idea now? Compare. See. If I don't say energy, you forgot. Photon is energy. Work function is energy. So get the idea. Always compare energy with energy, frequency with frequency. Thank you. Okay, let me test you something. So for example, let's say I have two balls here, one A, one B. Obviously, B bigger, heavier. Can I say a mass of A is heavier than B? Can I say this? Do you think this sentence acceptable? Oh, sorry. The B, mass of B is heavier than weight of A. Acceptable? Yes or no? Again. Thank you. I mean, thank you. Thank you. So, okay. Okay. Can say that. Yeah, very good. Yeah, answer is no again, because do not compare mass with weight. Mass is in kg, is a base unit. Weight in Newton is a derived quantity. So normally we say what? Weight goes to mg. They directly proportional, but still they are different things. Do not compare them in same sentence. Okay, very good, Shiqi. Right, now next. Dun, 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 a beam of light. So seems hard, not hard. A beam of light with frequency. Now, if they give frequency, normally you use E equals to HF lah. It's directed blah blah with the work function or they give everything already. Time constant. If they don't give, don't worry. It's here. Okay, calculate the light and the energy of light and the kinetic energy of emitted electron. Okay, the energy of light. So same thing lah. E equals to HF. Planck constant 6.63 times 10 powers of negative 34. Frequency 7 times 10 powers of 14 hertz. Now you will get okay, what's the unit? How can I get up to? What's the unit? Please check left hand side. E stand for energy. Thank you. Yes. Yeah, Joe. All right. Yeah, good. Very good, Shiqi. Capital. Okay, so actually, we can check here lah. The H is actually joule second. Then hertz actually is per second. So this two becomes 0 joule. So remember, hertz is per second. Now, kinetic energy. So let's recall. Okay, there are two ways to get kinetic energy. Number one, kinetic energy half mv squared. Do we have any information about mass? Nope. But of course, you can find a calculator. But come to another question. Do we have any information about velocity? Nope. So sorry, this is not usable. So wait, method number one. Method number two, you can use this formula. So because method number two, we use this formula. You might wonder why sometimes I write KE, sometimes I write EK. Doesn't matter, but actually the best is write EK because this is the physical quantity actually is energy. Work function, work also is an energy. So energy. Okay. So see the equation, we always write all in energy. So now the E just now we got already. Substitute here. W naught they directly gave already. So we can directly get kinetic energy. So remember we got two ways. for this topic, any photon, work function, kinetic energy, all got two ways. You can directly use their either you use their original formula, or if they give the other two, you can substitute and you just do the simple operation. Okay, so now what is your EK max? Right, what's your answer, A or B? Thank you, Michelle. Right, the rest. Thank you, Justin. Thank you, Junam. Thank you, Hanun. Thank you, Raisha. Oh, it's okay. Okay. Yes. Yeah, because the standard formula you all like not realize, not realize, not you all, some of you like not alert lah. So see if I change this to this, I believe you will. So x will equals to, maybe I make it like 3. So x equals to 1 or x equals to 4 over 3. 哦，好的，好的，可以，可以，差不多了，差不多。Okay, so actually this is plus lah, plus is minus lah, okay. Because I always want to use back this. Maximum 10 minus 4 equals to 6. So means 10 equals to 4 plus 6. Okay, right now this one very fast lah. This is light on metal electron photoelectric lah. Thermionic means you heat it up, lah. And this one, name the minimum frequency that allows electron minimum frequency to allow the electron to be emitted. Like anyone, fast. Anyone can tell minimum frequency. Minimum frequency. Yeah, so actually minimum frequency is the threshold frequency. Right? Pronounce with me. Threshold frequency. When you learn something new, please pronounce it out to tell your brain, okay, threshold frequency. They like threshold frequency. Threshold frequency. So, yeah, this is the definition of threshold frequency. Minimum frequency that allows electron to be emitted out from metal surface when light is illuminated, light is shone. When light shines on the metal surface. Need to memorize, So you need to memorize what? You need to memorize photoelectric effect, work function, threshold frequency. Normally they ask these three things only. Okay, now what will happen to the kinetic energy of electron when the intensity of light increases? Okay, yes, this one need to refers to the relationship between light intensity to kinetic energy and the number of electrons. Okay, we need to reverse back here. Just now I say, hold on. Yeah, here, hold on. So now, here got two sentences. One is the greater the light intensity, the more electron is emitted out. But the light intensity does not affect the emission of electron. Means the light intensity does not affect the kinetic energy. Does not affect the kinetic energy. For example, this is green light, 10 joules. 10 joules, 4 joules, get up 6 joules. Okay, so light intensity means brighter. Brighter means you can imagine this is one green photon, this is two green photon. So this one only got two green photon. Brighter means here you got three green photon. So what's the difference between green photon? More electron emitted out. So what you imagine, one green photon only affect one electron. So higher light intensity means more green photon, more electron out. But is it kinetic energy affected? No, not at all. Because kinetic energy depends on photon energy and work function. Okay. So now, for example, light. If you give more light intensity for red, also no electron come up because the photon energy is less than work function. So when we increase light intensity, we only emitted more electron up. But that's it. Light intensity does not affect kinetic energy because I will look at the formula. E equals to work done and kinetic energy. Does they tell anything about light intensity? Nothing. All right. So we only compare energy with energy and energy. So now what's your answer? What will happen to the kinetic energy when light intensity increases? Answer. Reason. Right answer. You increase light intensity. Will it affect the kinetic energy? Yeah, thank you. In Heng. Yeah, thank you, Tiffany. Yeah, correct. So remember, all of them only affected by frequency or the energy. That's why answer is no change, not affected. No. No change. Remains the same. Something like, okay, why? Because light intensity does not affect the magnetic energy. Or we can say the kinetic energy is directly, not directly, is affected by. If you want to say affected, you better say in front before affected by what, okay? Affected by photon energy. Remember, compare energy with energy. And I know you are very hungry now. One more. Sorry, give me 3 more minutes. Only 3 more minutes. Very easy, really very easy. By the way, this graph shows kinetic energy. You might see EV. You may ask, what is EV? So EV is energy, could be in joules or could be in EV. Their relationship is like joules and calorie or like cm inches, something lah. It's almost the same thing lah. Just different unit only. EV is unit of energy, another unit of energy. And the light frequency for two different type of metal. And you be careful about here. This is F in 10 times 10 powers of 14 hertz. So metal P, this is not so clear lah. This is not so clear. This one is at the center. I mean, this is 2.2. This one is center, so which is 4.2. This is 4.3. You don't think it's only 4.2, 4.3 or 2.2. You must look at this per 10 powers of 14 hertz. So usually you should write here times 10 powers of 14 hertz times 10 powers of 14 hertz. And I believe now you can guess already. So actually the x-intercept is F naught. F naught. This is the F naught for metal P and F naught for metal Q. Threshold frequency of metal itself. Okay, so now see, x-intercept is a threshold frequency, while y-intercept is a negative work function. So work function means what? Work function means they need to absorb this energy, then only electron is released out. So for P, it need to absorb this work function. For metal Q, it need to absorb this work function so that electron can be emitted out. That's quite easy, right? And by the way, the gradient is Planck constant. Okay, so very easy to see, right? X-intercept is threshold frequency. Y-intercept is work function. Negative means it needs to absorb this much energy, then only electron emitted out. Okay, what is meant by threshold frequency? Please refer back. Ta-da! Don't copy, memorize first. Then this one, compare the threshold frequency for P and Q. Of course, P is less than Q. Then compare the work function for P and Q. Don't count the negative. It means it need to absorb this much energy. This one you need to absorb 1.567 this much of heat energy going up, then only it can be released. Of course, P smaller than Q. So work function equals to HF naught. Right? So we also can say work function directly proportional to the threshold frequency. Compare the gradient. Gradient the same because gradient all are Planck constant. So no matter how many lines you draw, all same gradient. So gradient is the same because gradient is Planck constant. Like pi always the same. Relate the threshold frequency and work function. Refine back the formula directly increase. I prefer you do this. Say the Einstein photoelectric equation if gradient of the graph is m and work function is w. So we say E equals to work function plus Ke max. So the gradient of the graph would be m. Oh, sorry, cannot. This one we will leave it first. Then last. They say what? They say determine the gradient of the graph. What is the gradient of the graph? So gradient of the graph we for Q. So gradient of the graph you just draw. Since they give you grid, you determine, let's say here and okay, here and here. Please draw a gradient. Then you determine the x1, y1, x2, y2 here. Gradient equals to y2 minus y1 over x2 minus x1. And you take then what you do, just draw gradient. And don't forget, this is they once in joule. So y2, let's say y2 is here, y2 is 0.3. Yeah. So it's 0.3 minus negative 0, minus 1.0. Minus 1.0. This is EV. So change EV to joules is, after you do this, you times this. So 1 EV equals to this joule. So like 1 dozen of pen equals to 12. So if 0.5 dozen of pen is 0.5 times 12, answer is 6. So you just times this times 1.6 times 10 powers of negative 19, then divided by x in hertz. Okay, so you will get. Okay, so the rest you all do lah, do until try to do maybe up to up to 11 first. If possible, do up to 14. You don't know also, you simply choose first. Then I'll give you answer. Okay, so that's all for today. Sorry, extended 10 minutes. Okay, any question? Okay, no question. You can rest now. Thank you, everyone. Bye-bye. 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 Bye-bye.